Hey math kids, today we're going to talk about the shortest distance from a point to a line. And so let's draw a little diagram. So if we have a vector going this way, we'll call that B. This is point A, point R. Then we're trying to get to point P. The shortest distance, or perpendicular distance, from that vector to that point is going to be when PR and B have a dot product of 0. So this is just rehashing that same idea that the dot product of 0 means perpendicular. Okay, so we'll use that idea. So we have a vector equation that looks like this. And it says find the shortest distance from point P, which is 5, -1, to the line. So what we're going to do, we're going to have, so we have our vector, it's going this direction. And then we have point P, which is right here. We'll call this point N. And N is going to be x comma y. And so if we just take the x value right here, it's going to be 1 plus 3t. If we take the y value right here, it's going to be 2 minus t. Okay. And so if we want to find Pn, we're just going to take the n coordinates, minus, and then we'll take the p coordinates, and then we want to simplify that. So 1 minus 5 is going to give us -4, and this is like a plus sign, so 2 plus 1 is 3. Alright, so that's the simplified version of Pn, and we know, so once again, that's this. And if we want it to be perpendicular, we need to set it, do the dot product with the velocity vector, or the direction vector. So we're going to do Pn dot 3, -1, and we know that's going to equal 0. So if we plug in Pn, let me move this down a little bit. Okay, so dot product, we multiply common terms, and then we add that to the other common terms being multiplied. Okay, distribute. Combine like terms. And then just solve. Okay, and if we divide those both by 5, we get 3/2. Okay. And so that's our t value. And if we go back to the problem, it says find the shortest distance from the point P 5, -1 to the line. So this is not our value, or this is not our final answer, but this is the time at which the vector is perpendicular to P. And so what we're going to do is we're going to go back to our Pn equation, plug in our t. So we're going to get negative 4 plus 3 times 3 halves, and 3 minus 3 halves. So if we multiply that, let's actually just go to the side. Okay, we multiply that, it's going to still be negative 4 plus 9 halves, and then 3 minus 3 halves. If we get common denominators, this is going to be negative 8 halves. We combine that, it's 1 half. And then if we do the same thing here, times by 2, we get 6 halves. Then we get 9 halves. Okay. And if we factor out a, oh, why did it say 9? 6 minus 3 is 3. Okay, there we go. So that's 1 half, 3 halves. I multiplied instead of subtracted for some weird reason. Okay, so this is our vector. If we want to, we can take out a 1 half to make it look a little bit nicer, and so that would be 1, and that would be 3. And so there's that. And if we want to know the distance, we need to take the magnitude of this. So we can take it from either of these yellow boxes. It doesn't matter. This one we would do 1 squared plus 3 squared, square root. We get 1 plus 9 square rooted. So it's the square root of 10. And then we have this 1 half out in front. So we could rewrite that as 10, square root of 10 divided by 2. And that would be the shortest distance. If we did this one, we would just have to plug in 1 half squared plus 3 halves squared square root. Wouldn't have to worry about anything out front. This would be 1/4 plus 9/4. Add those together, we get 10/4. That's under a square root. If we square root the top and the bottom, we end up with the same thing on that one. Okay, we have another problem. Okay, so this time they give us a 3-dimensional point, P, and then they give us a line as a parametric equation. Okay, T is a real number. Okay, it says find the coordinates of the foot of the perpendicular from P to the line. Okay, so the first thing I'm going to do, I'm going to put this in, let's see, let's change the color, vector equation form. So the constants, 1, -4, 3, then we have t, then the t value is 2, 3, 1. Okay, so when we do that, we can see that we have our direction vector, and that's equal to this. And then if we want to find the foot, which is, you know, if we have this situation, and then we want to be coming to P right here, the foot would be A right there. Okay, and so to find A, we're going to get we're going to do 1 plus 2t, because here's our x value, -4 plus 3t, and t, just using those. Okay, and so if we find PA, we're going to write all our A values, minus, 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 and then we take our P values right here. Okay, this is like adding, so we get 2 plus 2t, subtracting negative 6 plus 3t, negative 3 positive 3, so that's just t. Okay, and then we want those to be perpendicular, so we're saying P of A dot B, and so we plug that in. B is right here. Okay, so we want that to be 0. And so when we do the dot product, I'm going to distribute a 2 to both these. Plus, and then distribute a 3. Distribute a 1. Okay, combine like terms. So that's going to be negative 14. Combine these, that's 10, 14. Okay, add the 14 over here. So 14t equals 14, which means t equals 1. Okay. And if we substitute the t equals 1 into the original parametric equations, that's going to tell us our point. So t equals 1, so it's going to be 1 plus 2 times 1 for our x value. Our y value is negative 4 plus 3 times 1, and our z value is 3 plus 1. So z equals 4, this is 3 minus 1, and so y is equal to negative 1, and then 2 plus 1, x is equal to 3, and so that point right here, point A, is going to be 3, negative 1, 4. Okay, now part B says find the shortest distance from the point to the line. Okay, so since it was perpendicular, we're going to use that same t value, and so we want to find like the actual value of PA at that moment, and so we're going to go back to PA, which here's one version of it, plug in a 1 for everything, so 2 plus 2 times 1, negative 6 plus 3 times 1, and then just 1. Once again, this is PA at that specific moment. So 2 plus 2 is going to give us 4. Negative 6 plus 3 is going to be negative 3. And then we just have 1. Okay, now to find the actual distance from that, we have to take the magnitude. So 4 squared plus negative 3 squared plus 1 squared, square root it. 16 plus 9 plus 1. So that's going to be 26. And that is how far away that is. If you need additional help, please come to Math Lab. Until then, calculate.